Hello grade 11s. In this lesson, we introduce two-way contingency tables, which are another way to summarize and represent data from a probability question. Contingency tables are used to show the outcomes of each event under consideration. The probabilities of the different events can then be calculated from the information in the table. Let's look at an example. Medical research provided the following statistics after a certain medical procedure was performed. 100 males and 80 females underwent the procedure, and 61 males and 49 females responded positively to the treatment. Is the success of the treatment independent of the gender of the patient? We can summarize the data from the question using a two-way contingency table. This is how we set up the table. We need to draw up a 4x4 table to represent all the relevant information. In row 2, we list the positive results. Row 3, those results that were not responsive to the treatment. And row 4 represents the total for each column. Then we have columns for the male results, female results, and the total of the positive and not positive results. Where the male and positive results intersect, we write 61, as 61 males had positive results. Then we fill in 49 females with positive results next to that. So the total positive results are 110. We were given that 100 males underwent treatment in total. So if the men total is 100 and 61 responded positively, that means 39 did not respond positively. Similarly, there were 80 females in total, and since 49 responded positively, that means 31 did not respond to the treatment. So the total in the not positive row is 70, and if you add the two totals in the column and row, you must get the total number of patients. In other words, males plus females, which is 180 in this case. Do you remember how to determine if two events are dependent or independent? If A and B are independent, then probability of A intersection B is equal to the probability of A times the probability of B. Conversely, if the probability of A times the probability of B is equal to the probability of the intersection of A and B, then A and B are independent. So let's use this fact and the contingency table to answer the question. Is the success of the treatment independent of the gender of the patient? Reading from the table, the probability of male and a positive result is 61 over 180, which is 0.34 rounding off to 2 decimal places. Now let's test the probability of male times the probability of positive response. From the table, we see that is 100 over 180 times 110 over 180, which is 0.34 rounded off to 2 decimal places. So since the probability of a male patient times the probability of a positive response is equal to the probability of the intersection of male and a positive result, we can say that the treatment is independent of gender. This means that the treatment success does not depend on the gender of the patient. Now, let's do another example. Why don't you try this one on your own? 40 light bulbs from 2 different batches were tested and the results were recorded in this contingency table. If a light bulb was chosen at random, determine probability that it failed, probability it was from batch B and passed, probability it was from batch A and failed. To find the probability that a random light bulb failed, we look at the total of the column with the failed bulbs and see that 4 bulbs failed. Therefore, the probability of a failed bulb is the number of failed bulbs over the total number of bulbs, 4 over 40, or 10%. The next question asks us to find the probability the random bulb was from batch B and passed. Probability it was from batch B and passed. This is the intersection of batch B with the passed column, and that gives us 17 bulbs. So the probability is equal to 17 over 40, which is 42.5%. And the last question asks us to find the probability that the random bulb would be from batch A and will have failed. We look at the intersection of batch A with the failed column and see that one bulb failed. So the probability it was from batch A and failed equals 1/40 or 2.5%. Thank you for joining us, grade 11s. Remember to look at the tasks for this section in the Using Probability task video. You'll also be able to learn more about probability on our website, www.mindset.co.za/learn. It's always good to have a contingency plan. Goodbye.